Hello, folks. It's time to talk circles. Yes, we are going to start getting back into things, getting back into the swing of things, and getting our geometry muscles flexing again. And we're going to do that with our introduction to circles. Now, what we're going to be doing for this lesson is we're going to be using a lot of online resources, which we think are fabulous. However, we thought it'd be interesting, at least, to start off with some basics so we could kind of frame the conversation for future. So let's first talk about what a circle is. Now, everyone kind of can draw a circle, and some people can draw better circles than others. But the first thing we want to think about when we think about a circle is what's like the definition. And a circle, by definition, is effectively all the points that are a certain distance from another point. So you imagine you have some point here, and you have some distance. Let's call it, I don't know, an inch. And that's about an inch on my screen. Now, if I said, let's take all the points that are an inch away from this center, and let's call this center, we'll call this center O. O is a common letter used for centers of circles. So we'll call this O, and we'll say this distance here is about an inch. Now, if we wanted to have all of the points that are 1 inch away from this, that would have to have this point. It would have this point here, that's about an inch away from O. That point is about an inch away. If I come over here, and as we start thinking about every one of these points, you're like, well, you could be there forever, right? You're going to be there forever drawing all of those points. And that's why what we do is we connect all these points and we make a circle. And freehand, sorry, it doesn't look like a perfect circle, but that's a circle. And a circle, by definition, is the set of points. And I guess I should say this in 2 dimensions, because we don't want to start talking about solids yet. Or on a plane, right? So the set of points in a plane or in 2 dimensions that are equidistant from another point. So that's like the definition of circles. That'll frame everything we're going to be doing for this unit. So let's go over a couple glossary of terms, effectively, things that you're going to need to know. Things that you may know already, so when you're going to be bored a little bit, but that's okay because we need to cover some things. Okay, so first of all, let's talk about this distance we talked about. That 1 inch in the previous problem is called a radius, and the radius is the distance from the center of the circle to any point on the outside of the circle. We often abbreviate this with a little r. R is kind of reserved for radius. And remember, every one of these, right? If I drew this one here, that's a radius. This here is a radius. This would be radius AC. This would be radius AD. They're all radii. A diameter is a line segment that goes from one side of the circle through the center of the circle to the other side of the circle. This diameter, you can call this, AC. We'll call this O. Diameter AC. And this has the length of 2r. And when we talk about diameter lengths, we'll call it 2r. We'll also sometimes call it little d. That'll represent the length of the diameter. A chord and secant line are related to each other. A chord is any line segment that goes from one side of the circle to another side of the circle. So this is chord AB. And notice one thing about this chord. This chord is not going through the center. So you may say to yourself, well, is a diameter a chord? Well, is a diameter have one point on one side of the circle and another point on the other side of the circle? Well, yeah. If 2 endpoints of the line segment are on the circle, it's a chord. So this is a chord. AC over here is also a chord. It's just a special chord. And a special chord that goes through the center of the circle is called a diameter. Now, most of the time when we're talking about diameters, we're going to call them diameters. Most of the time when we're talking about chords, we're going to be talking about chords that aren't diameters. So we're going to kind of reserve diameter in our conversation for something that goes through the center. And we're going to usually talk about chords as something that doesn't go through the center in our conversations. Let's talk about a secant line. A secant line is any line that intersects a circle in 2 points. So if we want to say, well, what does that mean? Well, any secant line effectively contains a chord. A secant line is a line that effectively contains a chord. A tangent line is different. How is a tangent line different? A tangent line also intersects, but it intersects only at one point. And it's going to look like that. So a tangent line also intersects a circle, but instead of intersecting at 2 points, it may intersect it only as one. If we wanted to call this tangent line, this secant line, we would call AB with the arrow on top. And this tangent line, if we wanted to call it something, we'd need like another point somewhere, and we could then call it CD. So now let's talk about angles. A central angle is an angle who has a vertex at the center of the circle. So let's draw any old angle here. It's not particularly straight, but there's some angle, right? There's some angle. And we'll use various abbreviations for this. One of the common abbreviations that people use for angles is theta. We won't necessarily use theta all the time, but you'll see theta when you're working with angles in this unit with some of the online resources. So why not introduce it to you now? But this theta could be the measure of this angle also. We could also label it, right? We could call this A, call this B, we call this O. So we could also call this central angle, angle AOB. Right? So theta would be maybe the measure of that angle. Maybe it's like 30 degrees. But angle AOB is the name of the central angle. And please note the vertex has to be at the center of the circle to be a central angle. An inscribed angle is a different angle. An inscribed angle has the vertex instead. The vertex, we'll call this B. The vertex of the inscribed angle is on the circle. So inscribed angles have a vertex on the circle. Central angles have a vertex at the center of the circle. So that's called ABC. When you start talking about inscribed angles, you may say to yourself, well, what's going on here? See this, there's this AC here. This is kind of like a portion of a circle we're about to talk about. This here is also a portion of a circle that we're going to talk about. Well, the angles, whether it's centered, or whether the vertex is at the center, or whether the vertex is on another point on the circle, will make a big difference in how you calculate the measures that we're going to be talking about in this unit. So an arc, we're just moving along. An arc, we call this arc is like a portion of the circle, right? This arc, we could call this A, B. Now it's not a straight line, right? Since it's not a straight line, we don't want to call this AB with a line over it because it's kind of a curve, right? So what we're going to call this is AB with a little curve on top. That says that it's an arc. And it's just a portion of the outside of the circle. When you think about AB, it's like, okay, yeah, this is a portion, this is the whole circle. AB is a portion of that circle. Some people would say that it's part of the circumference. When you're thinking about the measure of it, it's definitely part of the circumference that we're going to get into. One other thing that's kind of important for us to also understand is that when you have A and B, you need to make sure that you're defining whether or not this arc is like this arc here, or what if we want to go around the wrong way? And I say wrong way, maybe it's the right way, but what if we want to go around this way here? That's also going AB, right? So how do you differentiate between the two? Well, there's a kind of the small arc, right? And the small arc is what we're going to call the minor arc, because it's the smaller. If you're thinking about going from A to B, you could go the short way or the long way, right? So the short way is always called the minor arc, and we always give it 2 letters. But if we wanted to have the major arc, say going the long way, we'd have to give another way of kind of defining it. And the way we define it is we put a point somewhere else on there, anywhere all along the long way, and then we'll call this ACB. So major arcs get 3 letters. And you have to have a letter somewhere to just to signify that, hey, you're going the long way, you're not taking the short way. Sectors. When we talk about sectors, basically saying it's like a piece of pizza. A sector is a portion of the area. So just like an arc is like a portion of the circumference of a circle, sector is a portion of the area. And a sector can be small. Like you could have like a very small piece of pizza, right? Sometimes you get really angry if you get like the kid slices when you were a kid. But sometimes you could say, well, I want to eat half the pizza, right? Yeah. Well, a sector, half a circle, it's to be called a semicircle, but could also be just a really big sector. It could be any portion of the area of a circle. In fact, if you wanted to think about this, you could say, what about this part here? What if I wanted to have all of this? It's like Pac-Man. Well, yeah, that also is a sector, just a big sector. Any portion of the circle is going to be a sector. So they're the three main topics. There's a couple other things that we're going to talk about just because they might come up. I mean, I think we're going to define them pretty clearly when we do wind up getting to them. But so I'm going to go pretty briefly here just to give you a couple more definitions, just to prepare you for the lessons ahead. When we talk about concentric circles, what that means is basically two circles or two or more circles with the same center. So it's really easy to draw concentric circles. I can say, hey, here's a circle, right? The given circle is a given circle. Well, there's a concentric circle, right? They share the same circle. Here, this one here is a concentric circle. I mean, they share the same center. They share the same center. So you could do a really big circle. You could do a really big circle out here, right? You could say, oh, really big circle. Yeah, as long as they share a center, they're called concentric circles. An inscribed quadrilateral is a quadrilateral that has all four of its vertices on the outside of the circle. And it's inscribed because each vertex is on the edge of the circle. We're going to do a lot of inscribed polygons and inscribed shapes in this unit. A circumscribed quadrilateral is something where instead the quadrilateral is actually on the outside and it barely touches the circle. So we got that. We got that. We got that. Oh, I went too far. That should have been straight. I'll undo it. And then that's not too bad. Okay, so please note that these 4 points, the lines are barely touching. They're barely touching the circle. And we learned when we have lines that barely touch the circle, the quadrilateral is effectively made up of 4 tangents. Because we just talked about moments ago that a line that barely touches the circle, it only touches one, is called a tangent. And we're going to be talking about circumscribed quadrilaterals in this unit as well. So there's your kind of basic terms, folks. That's going to help you get started. Looking forward to working with you in the weeks ahead as we dive into circles and get through some of these exciting topics. Talk to you soon.